Hey everyone, in this mini lecture we're going to be discussing the topic of the chain rule. So there are special moments in calculus where we use the chain rule. So if we start off with the composition of functions, so in this case it's f composition g, right? This derivative can be found by taking the derivative of what we have here, that composition, f composition g of x. In essence, it's saying to take the derivative of f of g of x, right? Where g of x is just inserted into f of x. And our chain rule tells us to find that derivative. We can take the derivative, we'll have f of x and g of x. We take the derivative of the outer, so that's why I'm denoting f prime, while keeping the inner function the same, which is the g of x, and then multiplying that times the derivative of the inner function. So once again, the chain rule says to take the derivative of the outer while keeping the inner the same and multiplying times the derivative of the inner function. Okay, so let's go ahead and give this a try. Our example says to differentiate. We're going to differentiate f of x, the function f of x, equaling 1 plus x to the third raised to the 1/2 power. All right, so I do see a function within a function, right? We see the 1 plus x to the third, that's one function within the bigger function of that quantity raised to the 1/2 power. So it's a function within a function. So my inner function is the 1 plus x to the third. My outer function is that quantity raised to the 1/2 power. So first, the chain rule says to take the derivative of the outer function, right? The outer function is that quantity raised to the 1/2 power. So I can apply the power rule right there and say it's 1/2 times 1 plus x to the third. And what does the power rule say? Remember, we subtract 1 from the exponent, so 1/2 minus 1, 1/2 minus 1 gives us a negative 1/2. And then if you go back to our chain rule, it said to now multiply this times the derivative of the inner function. Well, the inner is what's inside the parentheses, 1 plus x to the third. The derivative of 1 is 0. The derivative, and we add that to the derivative of x to the third, which is 3x to the second. We'll get 3x to the second. Okay, so now we've completed the chain rule. It's a matter of just cleaning things up a little bit. We have this 1/2 at the front, and we have this 3x squared there. We can multiply 3x squared times that 1, right? And we'll get 3x squared. And this is still over 2. And then it's still times the 1 plus x to the third to the negative 1/2 power, right? So now we can go ahead and say, let's just take a look at that negative exponent. That negative exponent right there. What does that mean? That means if we have 3x to the second in the numerator, that negative exponent brings that whole quantity to the denominator, that 1 plus x to the third, right? While the 2 is already there. However, it's a rational exponent, right? A rational exponent to the 1/2 power. That tells us, if you recall from your algebra, to make that a radical of 1 plus x to the third, right? Because the fraction, that 1/2, that 2 is the index, and that 1 is what we're raising that whole radical to, and then that will be it for us. In our next problem, we have y is equal to the quantity of x squared plus 1 raised to the 5th power, and we're told to find y prime, so basically find the derivative. So I see an inner function, and an outer function, right? The inner function is x squared plus 1. The outer is that quantity raised to the fifth. So I can apply the chain rule. The chain rule says to take the derivative of the outer. So we apply the power rule. So that becomes 5 to times that quantity. And then remember the power rule says to subtract 1 from the exponent. So 5 minus 1 makes the 4. And the chain rule says to keep the inner function the same. And then it says to multiply times the derivative of the inner function. Well, the derivative of x squared is 2x plus the derivative of constant, right, is 0. So 2x plus 0 is 0. So it's times 2x. And now, again, just like in our previous problem, it's just a matter of cleaning things up a little bit. Maybe we can go ahead and multiply the 5 and the 2x to get 10x. And then that's times the quantity of x squared plus 1 to the fourth power. So this is what y prime is equal to. All right, and our next example says that y is equal to sine squared x, and we're told to find y prime, so find the derivative. All right, so we can rewrite this, right? If you recall from your pre-calculus or trig, that sine squared x really just means sine x to the second power. All right, so now looking at this, I see a function within a function. So the outer function is that quantity squared. The inner function is the sine x, so we apply the chain rule. So the chain rule says that we can take the derivative of the outer. So the outer is that quantity squared. So we can use the power rule. And then we subtract 1 from the exponent. So 2 minus 1 becomes a 1. And then the chain rule says to keep the inner function the same. And then lastly, it says to multiply times the derivative of the inner function. The derivative of sine x is cosine x. All right, and now we can just say, okay, y prime is equal to, we know we don't need the parentheses, and we don't need to raise it to the first power, that's implied. Y prime is equal to 2 sine x cosine x. All right, maybe if you were taking a multiple choice test or something like that, you can apply your different formulas. So by the double angle formula, if you recall that one, from your pre-calc days, then you would say, okay, maybe y prime can be rewritten as sine 2x, right, by the double angle formula. So what we've done is use the chain rule to differentiate functions within other functions.